Okay, so Pablo, this is Pablo. I'll put a P on his shirt for Pablo. Pablo is spinning this prize wheel, shown. A spin can be clockwise, so that's the way that a clock goes, or it can be counterclockwise. So it says define these two words in your own, words in your own words. So what does clockwise mean? So the way a clock goes. The way a clock goes. Everybody's filling this word in right here, the way a clock goes. What is counterclockwise? Yeah.
The opposite of the clock?
The opposite. I'm just going to do the opposite of that. You guys okay if I just put arrow? Okay. It says if the section labeled 8, so that's this one, right? And this one. If section 8 on the left part of the wheel spins 90 degrees clockwise, where will it land?
3.
Yeah, where the 3 is. Good, because it would turn, says clockwise, right? So it would turn this way 90 degrees, makes it look like the corner of a paper. So here's the corner of a paper, and it would turn and be in the same position as 3. So turn that's 90 degrees, because I used the corner of a paper. So it would be in the position, so I'm going to put where 3 is. 3 is at the top. Okay. If one of the sections labeled 4, so where's the 4? Here's a 4, and there's a 4, makes 3 complete turns counterclockwise, how many degrees will it have traveled? So but 4 complete turns. Okay, 3 complete turns. So 1, 2, 3. How many degrees will it have traveled altogether? 360, good, times 3. Use your calculator. So we got 1,000, you guys agree 1,280 degrees?
Yeah.
Nice. And would it be in the same position?
Yes.
Yes, and then we're going to put same position.
It should be 1080.
Yeah.
1080? 1,080, okay. It's a good thing we have calculators to check our work, right? Okay, are there any points on the wheel that stay fixed or do not move when the wheel spins?
I know. Wait, yes.
Where?
The center.
The center. So that would be the center. And you can say the center doesn't move. Okay. Then the next question. Does the center of the wheel change when the wheel is spun counterclockwise versus clockwise?
No.
Nope. And then does the distance from the center of the edge, so the distance from that center to an edge, so like straight out like this, does that ever change as it spins? No. What is that called? What is the distance from the center to the outside of a circle called?
Circumference?
Close. It's close to circumference. It's the radius.
Oh, yeah.
No, it's the radius. Okay. Next page. So a rotation is a transformation in which the figure is rotated, turned about a fixed point. The center of rotation is the fixed point. A rotation does not change the size, so it does not change the size, and it does not change the shape of the figure. So the pre-image and the image are congruent. Do you guys recognize that word congruent? Did you guys underline size and shape? Maybe put does not change the size and shape, underline that whole thing, and then put the word underline congruent. So does not change the size and shape, underline that. And then those are congruent. So then it tells us things like this. So triangle LMN has those locations, and then he wants to rotate the counterclockwise 180 degrees about vertex L. So graph the figure and its image. Then give the coordinates of the vertices for L prime, M prime, N prime. So I think it's really easy to look at one of the lines. So they looked at this line right here and they said, okay, 180 degrees just means that it's going to go all the way around. So it's just going to go down instead. You can do that with any of these lines. See the diagonal line? If it rotated down, it would just make a straight line. But then what is the relationship between MN and M prime, N prime? Are they perpendicular? Are they parallel? Like this line right here and this line. Are those lines parallel or perpendicular? They're parallel. Good. Okay, so then we would graph it. They used a protractor. We're just going to use normal things because we only have to do 90, 180, and 270, and that is all things that you can do with a piece of paper, the corner of a piece of paper, or a piece of paper itself. So they did that. That's going to be kind of tricky, but let's try this one. So rectangle ABCD with vertices A here, B here, C here, and D here. We need to graph those.
This is the correct graphing. Over 7 up 4, that's the real A, that's the real B. Negative 2, 1 is C, and then this one is D up here. So then I'm going to make it a rectangle. No, this wasn't going to take too much longer. Okay, and then graph the figure and its image after a clockwise rotation of
So graph the image, and so we graph the image, figure and its image after the clockwise rotation of 90 degrees about center C. So here's center C, and it works really nice if you just look at one of the lines. So I'm going to pick this vertical line right here. And what would 90 degrees do to that? Like if I were to put my finger there, so it's kind of like I'm putting my finger on the corner and turn it 90 degrees clockwise, what is that going to do? What is it going to do? Yeah, it's going to go like this instead, right? So it's going to go like this. So the line that's right here is going to be instead a horizontal line. Does that make sense? C is the anchor. It's that center of rotation. So,
I figured out why horizontal is
right now,
horizontal, 'cause, like,
it's
how
3.
wide is it?
Yes, good.
It's horizontal.
Good, horizontal and horizon. So those are my bad points. I should like cross those out. See what happens when I do it in pen? Yeah,
How do you find the anchor?
it says it in the problem. It says rotate it about vertex C. So if you want to put over here that that's our anchor, then you can. So there's that, and it's 3 high this way, so when it's horizontal, it still has to be 3. So right here is my D prime. So then we want the A to be, it's going to have to be, because right here it was straight down from it, now it's going to have to be straight above D, and that distance is 1, 2, 3, 4, 5. So we're going to graph up 5. 1, 2, 3, 4. Yep, it will be both C and C prime. Isn't that crazy? And then B is going to be next to A prime, and that's got to be right here. B prime. And then so C is C and C prime. So that is that's our image. Before we draw it, that's called the pre-image, but the book doesn't say that. They just call it the figure. Okay.
I don't feel so good.
So now we need to give the vertices for A, the new A prime, B prime, C prime, and then I'm gonna just leave things like this. Then we need C prime and D prime. Which one for sure stayed the same that we already know? C, so I can just really just write it again. So -2, 1. The nice thing is because we have the graph, we can figure out these other things. What is the location of A? What is that location? How far does it go over? I mean, A prime. How far over from the center? 1, good. And then it went up 6, good, good. Where's B prime?
-2.
-2, 6, good. And then D prime? What's that? 1, 1, nice work. Okay, the nicest thing, so that's what happens when you do across one point. There's not really a general rule that you can say, this is what you always do when it goes across, when it's rotated about a certain vertex that's not on the origin. But the cool thing is if it's rotated across the origin, it follows some cool rules. So if the center, like if the very center of the graph is like what you're rotating it around, right? So instead of us like grabbing a corner and turning it like that, it's like grabbing it like here and then turning it like that. Does that kind of make sense what we're doing? But it follows some cool rules. So instead of having x, y, the x and the y switch, and then what happens to the x? The x and the y switch, and then what happens to that x?
Becomes negative?
Yeah, it becomes negative. So that's if it's 90 degrees. If it's 180 degrees, what's the difference between this point and that point? Yeah, they both become opposite. And then what's the difference between this point and that point?
Only the y becomes negative.
So, and then what else happened? The y became negative, and then what else? This one x, y, and this one y, x. So what else happened? Yeah, they switched places, right? So the x and the y switched, and the y became negative. How was that different from the 90-degree one? X and y switched, but what happened on this one? The x became negative. Good. So these are kind of cool. These are really cool things. I want you guys to I want you to put underneath here 90 degrees, 180 degrees, and 270 degrees, and then put a box around them, because this is going to be very helpful. Helpful. This part right here. And if you want to make it look fancier, you can.